Hello, welcome to the course on geomorphology for the Jyoti Vidyapith Women's University. This is the course for geography, and the paper for that we are going to discuss in this lecture is on geomorphology, which is a branch of geography. Basically, when we define geography as it is a study of human and nature interaction and how the humans shape the environment and how the environment shapes the humans. And as per the Richard Harshon, who defined geography as the study of as a field which is concerned with the accurate, orderly, rational description and interpretation of the variable character of the Earth's surface. So broadly, we divide geography into two categories. First is physical geography that deals with the physical aspects, and second is human geography. In physical geography, there are different branches like geomorphology, oceanography, climatology, biogeography, pedology, etc. And in human geography, there are also various branches like economic geography, population geography, political geography, historical geography. All these are important fields of geography, or medical geography. All these are important fields of human geography. So we'll discuss various branch of physical geography, and in it we will discuss geomorphology. So geomorphology is basically a branch of physical geography. Okay, and when we talk about geomorphology as a discipline, as a subject, the word geomorphology has been derived from the Greek word geo, and which means earth, and morpho and logos, meaning forms and study. Okay, therefore, geomorphology is literally the study of earth forms and various surface features on the Earth's surface. Geomorphologists are primarily concerned with the study of Earth's superficial features, including their origin and evolution, and impact on human activity. Okay, that is the we can say that is the literal definition of geomorphology. So, geomorphology is the study of landforms, their processes, form, and sediments at the surface of the earth. This study includes looking at landform landscapes to work out how the earth surface processes such as air, water, and ice can mold the landscape. Landforms are produced by erosion or deposition, as rock and sediment is worn away by these earth surface processes and transported and deposited to different localities. The different climatic environments produce different suits of landforms. The landforms of deserts, for example, such as sand dunes and ergs, are a world apart from the glacial and periglacial features found in polar and subpolar regions. Geomorphologists map the distribution of these landforms so as to understand better their occurrence. Okay, so geomorphology is the systematic description and analysis of landforms and the processes that create or modify them. Okay, as the study of landforms, geomorphology helps to explain the evolution of the physical landscape, often referred to as relief. Landforms are the result of physical forces referred to as geomorphic processes, And these processes are broadly divided into internal, that is endogenetic, and external, that is exogenetic. The internal processes include movements of the Earth's crust that build surface relief by means of diastropism, that is folding and faulting of rocks, and volcanism. The external forces, on the other hand, are those that sculpt the landscape through weathering, mass movement, and fluvial, glacial, and coastal topography, coastal features. Okay, that is the so basically, geomorphology is the study of landforms and landform evolution. The topic traditionally has been studied both qualitatively, which is the description of landforms, and quantitatively, which is process based and describes forces acting on Earth's surface to produce landforms and landform change. The shift to a more quantitative approach was largely based on the work of Houghton, Stroller, and Leopold in the 1940s and 50s, who advocated a physically based assessment of landforms. Today, quantitative approach is widely utilized, demonstrated by modern process geomorphology textbooks. There are many subdisciplines in geomorphology, including tectonic, fluvial, storm, alien, floodplain, glacial, groundwater, climate, tsunami, and many others. These subdisciplines are mainly driven by distinctions in the mechanics and dynamics involved in the processes. Engineering geomorphology is the study of how geomorphology and geomorphic processes, okay, geomorphic processes have and may impact sites of engineered works, and typically is additional to the physical processes acting at a site. Human geomorphology studies impacts the humans have worldwide on reshaping landforms. Thus, it is difficult to imagine a location or circumstance that has not been impacted by geomorphic processes. Okay, so in geomorphology, there are some like we often mention the word landform. What landform means? So landform is an element of the landscape that can be observed in its entirety and has consistence of form. Another term that we used is landscape. Landscape, that Earth's surface. Landscape is the Earth's surface that's composed of an assemblage of subjectively defined lesser surfaces. Then another term, geomorphic system. Geomorphic system is a set of related landforms and processes, usually defined in terms of a dominant agent of geomorphic activity, that is water, gravity, ice, wind, waves, or organisms. Then there are different types of geomorphology and different approaches of geomorphology. First is physical geomorphology. Okay, it's the explanatory description, analysis of process mechanics, modeling, geological and engineering oriented geomorphology. Then second is environmental geomorphology. Environmental geomorphology is concerned with the regional description, geographical relationship of unique landscapes to environmental variables. Third is climatic geomorphology. It deals with the regional landscapes, morphogenic regions, and are related to distinctive climates and geomorphic processes. Another is climatogenetic geomorphology. It's a recognizing successive periods of relief development, explaining historical development of landscapes in terms of past and present processes. Then another is quantitative and process geomorphology. Uh, it focuses on rates and mechanics of contemporary exogenous processes, experimentation, and the evolving modern landscape. Then another is theoretical geomorphology. It's the mathematical expression of processes, detection of form, and landscape evolution from physical principles. Then there are one important terminology that's used and some few important terms like structure, process, and time that is used often in the geomorphology. So structure is the physical and chemical properties of rocks and sediments. The geological framework and it determines resistance to forces generated by geomorphic agents. Second is process. Process is a distinctive mechanism for the transfer of rock and sediment and thereby the creation of modification of landforms. It represents a force acting on the landscape in a response to the availability of energy, that is solar, gravitational, molecular, and geothermal. Then time. Time is the interval over which driving and resisting forces interact to alter the landscape to a definable extent or stage. Okay, so Earth surface processes are forming landforms today, changing the landscape, albeit often very slowly. Most geomorphic processes operate at a slow rate, but sometimes a large event such as a landslide or flood occurs, causing a rapid change to the environment and sometimes threatening humans. So, geological hazards such as volcanic eruptions, earthquakes, tsunamis, and landslides fall within the interests of geomorphologists. Advancements in remote sensing from satellites and GIS mapping has benefited geomorphologists greatly over the past few decades, allowing them to understand global distributions. Geomorphologists are also landscape detectives. Okay, they're also landscape detectives working out the history of a landscape. Most environments, such as Britain, and Ireland have in the past been glaciated on numerous occasions, tens and hundreds of thousands of years ago. These glaciations have left their mark on the landscape, such as the steep sided valleys in the Lake District and the drumlin fields of central Ireland. Geomorphologists can piece together the history of such places by studying the remaining landforms and the sediments, often the particles and the organic material, such as pollen, beetles, diatoms, and macrofossils preserved in lake sediments and peat can provide evidence on past climate change and processes. So, geomorphology is a diverse discipline. Although the basic geomorphological principle can be applied to all environments, geomorphologists tend to specialize in one or two areas, such as alien, that is desert geomorphology, glacial and periglacial geomorphology, volcanic and tectonic geomorphology, and even planetary geomorphology. Most research is multidisciplinary, combining the knowledge and perspectives from two contrasting disciplines, combining with subjects as diverse as ecology, geology, civil engineering, hydrology, and soil science. Okay, so now the topic is importance of geomorphology. First one is to understand geomorphological processes of various environments. Second is to detect natural and environmental hazards efficiently. For example, earthquake, flooding, landslide, tsunami, volcanism, etc. Third is to identify various landform features and landscapes. Another point is to identify various landform features from satellite images. Another importance is coastal and river research that's being done in geomorphology or with the help of geomorphology. Also, geomorphology also studies the vulnerability assessment. It also studies the vulnerability studies. Another is it's related with geology, geography, archaeology, engineering, planning, mining, construction, urbanization, the changes in the urbanization, and all that. Okay, so this is about the meaning and concept of geomorphology and importance of geomorphology. Okay,